Hello. So, in this slide, we will be dealing with a very important topic. Actually, more than an important topic, this is actually a topic that will actually make us learn how exactly wide is the horizon of physics, horizon of applied physics is. Spectroscopy, as you all know, is an important tool in material analysis. It is used in several distinctive fields. It has certain industrial application. In addition, more significantly, it has many medical application. Hello all, I am Aravind. So today we will be dealing with a very small discussion on application of FTR spectroscopy in medical diagnosis pathology. എങ്ങനെയാണ് എഫ് ടി ആർ സ്പെക്ട്രോസ്കോപ്പി അല്ലെങ്കിൽ ആസ് എ ഹോൾ സ്പെക്ട്രോസ്കോപ്പിക് ടെക്നിക്സ് മെഡിക്കൽ ഡയഗ്നോസിസ് രോഗനിർണയങ്ങൾക്ക് ഉപയോഗിക്കുന്നതെന്നാണ് പറയാൻ പോകുന്നത്. ഇതൊരു വലിയ ടോപ്പിക്കാണ്. ഇറ്റ്സ് എ വെരി വൈഡ് ടോപ്പിക് ആൻഡ് വി വിൽ ബി ഡിസ്കസിങ് ഇറ്റ് വിത്ത് ദ ഹെൽപ്പ് ഓഫ് എൻ എക്സാമ്പിൾ. നമ്മളിതിനെ ഒന്ന് ചുരുക്കി വി വിൽ ബി റെഡ്യൂസിങ് ഇറ്റ് ബൈ യൂസിങ് എൻ എക്സാമ്പിൾ. ലൈക്ക് വി വിൽ ബി ഡീലിംഗ് വിത്ത് എ particular disease called fibromyalgia and the spectrochemical analysis in blood plasma combined with chemometrics for fibromyalgia detection. So fibromyalgia, as you can see in the background of this particular slide, is a very chronic disease having these much what you call as symptoms. So we'll be dealing with fibromyalgia. Yeah. Moving on to the symptoms. These all are the symptoms of fibromyalgia. So fibromyalgia is a chronic, long-lasting disorder that causes pain and tenderness throughout the body, as well as fatigue and trouble sleeping. Scientists do not fully understand what causes it, but people with disorder have heightened sensitivity to pain. There is no cure for fibromyalgia, but doctors and the other healthcare providers can help manage and treat the symptoms. Treatment typically involves a combination of exercise or other movement therapy, psychological and behavior therapy, and medications, which means that fibromyalgia is a chronic disease. Till this moment we are discussing, it has no complete cure. Actually, scientists are researchers are in a hurry or in a journey to find a proper solution for a proper diagnosis system and treatment system for fibromyalgia. And at this point, we treat fibromyalgia by giving physical and psychological support and behavioral therapy and medications, because it will completely deteriorate all the human body systems, including the physical, mental, and even it will affect the social life of the patient. Moving on. ATR, FTR, an effective tool in fibromyalgia diagnosis. We are coming to our point, our necessity. So ATR, FTR, attenuated total reflection Fourier transform IR, is an effective tool in fibromyalgia diagnosis. We'll be looking how this ATR, FTR can be used for detection of the chronic disease like fibromyalgia. Novel spectrochemical analytical approaches play an important role as a new innovative technique towards the clinical diagnostic. So actually what we are here saying is that FTR spectroscopy, along with all other spectroscopy, has evolved to be a potential tool to identify and diagnose diseases. Actually, making use of spectroscopic techniques is now an emerging trend in the medical field. Since the last end of the 20th century to the present, several researchers are on this particular matter of using the spectroscopy to analyze biological fluid. So the next question arises is, what is biological fluid? Biological fluid, as the name suggests the fluids from human beings, plants, etc. Like you may wonder what actually this fluids from human being. It even includes human saliva. It goes from human saliva, human semen, human blood plasma, human serum, and all. So actually these are being employed under spectroscopic study to identify their properties and to diagnosis by comparing these properties with an affected individual. So this is actually the technique we are following in a spectroscopic pathology or spectroscopic diagnosis. It is so interesting to note that many researchers on FTR spectroscopy and biological field are not only conducted by physics persons or individuals from physics field, but from people who are medical professionals, people who are graduated in medical sciences. So this is actually an interdisciplinary field, or they can even be described as a field, basic science gifted to the medical science. So fibromyalgia discussions, diagnosis will be discussed in detail now. A metabolomic fingerprint profile for fibromyalgia and other rheumatoid disorders using IR and Raman spectroscopy, where the spectrochemical signature included these all components, like as you all see, CH bending in collagen, phospholipids, amide 3, CO linkage, skeletal CO linkage. So actually what actually he was saying is that I'm not reading this line by line. Actually here they are saying that for every particular organic or inorganic component, the biological components of the biological fluids, we have a characteristic peak. Actually, if we are a healthy individual, if a healthy individual is giving his or her or that individual's blood sample or a plasma sample, before that, let me make clear you how plasma is converted or separated from blood. Actually, it is separated from blood using centrifugation. The centrifugation technique. There is a machine called centrifugal machine. So we usually separate plasma from other components of blood using this centrifugal machine, using a simple technique. Okay. So actually, every component of this blood plasma in fibromyalgia detection, we use the blood plasma. The biological fluid is not saliva or serum or semen. It is human blood plasma. So actually, every component of the human blood plasma has identical or characteristic peak. Every component has an individual peak system, like amide, CC or skeletal COC linkage or glycosaminoglycans. Everyone has a characteristic peak. So what actually we do is that we will be comparing the data of this characteristic peak with a healthy individual. Likewise, we are already evaluated, we are already found the components of the possible components or possible peaks of a healthy individual's blood plasma. We will be comparing the variation, we will be comparing and identifying the variation by using the spectral bank collected already. So there is actually a data set. We will be comparing. ഇതിൽ എന്താണ് വ്യത്യാസം വന്നത്, നേരത്തെ ഉണ്ടായിരുന്ന ഹെൽത്തി ഇൻഡിവിജ്വലിൽ നിന്ന് ഇവിടെ എന്താണ് മാറ്റം വന്നത്. We will be comparing that. Moving on. Significance of study. Significance means why we need to study. ഇതൊക്കെ എന്തിനാണ് നമ്മൾ അറിയുന്നത്. Like as I already mentioned, several techniques are there. Although nothing is 100% successful, several techniques are there for the possible diagnosis and pathological treatments of fibromyalgia. But we are on a way, or we are finding a path to identify, to understand possible pocket-friendly, economically viable technique for understanding or diagnosing this fibromyalgia. So the technique using the spectroscopy is comparatively simple, cost efficient, and these people from Brazil, as you all know, Brazil is a very populated country, not as much populated as our country, but although it is a populated country, but the case of fibromyalgia is a bit complicated in Brazil. So we will be saying, this is the one research study is being conducted by people of Brazil, researchers group from Brazil in collaboration with that from UK. So actually we need a cost-friendly, simple, time-saving methodology for diagnosing this fibromyalgia. So that is a significance. Okay. Sample collection. Let us understand more about the application of FTR by looking on a research study conducted by these much people from UK and Brazil. I'm not reading all those names of these people. You can just Google on their names because all of them are famous scientists. Many of them are from the 2% scientist group. So actually they are from UK and Brazil, as I already mentioned. So actually they have used this FTR for the detection of fibromyalgia. So how is sample collected? It is very important. It is very interesting to note that in case of the biological fluid, especially fluid from human body, the most significant or most careful part which needs most of our care is the sample collection. So actually in this case, the case study we are looking at, 126 patients affected by the disease and 126 not affected patients are undergone for the study. The duration of collection of the sample were from July 2018 to March 2019. It was done in Federal University of Rio Grande do Norte in Natal, Brazil. Socio-demographic data. So you may all think, why the socio-demographic data is being here? This is actually for understanding, if any, it is not sure if any connection between their gender, age, education level, occupation, and marital status and ethnicity. So actually, if you are finding some researches, you may even find religion as a trait to understand the distribution of a particular trait in particular religion, between particular religion. Here they hadn't considered religion, but they hadn't considered the ethnicity. So moving on. 10 milli of the blood were collected from each patient in the same day. Also, all patients, that means 252 people, all the blood samples were collected. 10 milli of the blood sample. That's why that's one of the major advantage. Like we only need a small amount of sample for our diagnosis. Spectrochemical analysis. The samples were stored at minus 15 degrees Celsius before spectrochemical analysis. A Bruker Vertex 70 FTR spectrometer coupled to an ATR Helios attachment was used to spectral acquisition. See, the blood plasma is stored under minus 15 degrees Celsius. I hope and I think they had used the sample in between 2 or 3 weeks, because if we are storing the blood plasma sample for temperatures less than minus 15 degree, that means if you are storing it for minus 1 degree or minus 10 degree, it will only last for 2 or 3 weeks. So but it is very interesting to note, if you are storing it in a temperature like minus 80 degrees Celsius, blood plasma could be stored even for 2 years. Even a blood plasma collected from before 2 years could be used for the current study if you are storing it for minus 80 degree. So we can understand from this minus 15 that they had used it spontaneously, maybe between 1 or 2 weeks. So, and the FTR, the specification of the FTR spectrometer is mentioned there. The ATR crystal was clean. The ATR crystal is a diamond crystal. You may all Google the photos of FTR. Maybe you had all seen an FTR, at least in pictures. And this is a diamond crystal. Okay, moving on. The blood plasma is in liquid state. It is not being sublimated to make as crystals. It is in the liquid state itself. Moving on. Results and discussion. So these are the two graphs. These are the two graphs of our interest. See, these are case and control. Control means people who are not affected. That means non-patients who are normal, who don't have fibromyalgia. In medical terms, a control group is a group which is considered as without that trait. What trait we are studying here? It is fibromyalgia. So a control group refers to a group of people or sample without that particular trait. So actually this is the variation of graph. You can see the graph. You can see the graph. You can see the variation of case and control. You can see the variation of case and control. Like, see, the blue one is the control and the case one. The peak excitation is very different. See. So this is actually row spectra and mean process data for the case. So this is actually the mean spectra of the case. You can see the red variation. You may find it interesting that there is no much variation, but this much variation is even significant. Okay, moving on. These are the control and patients. That means every peak is assigned with a particular assignment. That means amide 3, collagen, amide 3, phosphodiester region. So there will be variation from control group to the affected people. Moving on. inference. Variation is in spectra of control group and patients is identified. So there are variations in the spectra of patients and control group. So these are the reference. This is one single reference. You can Google this, any one of the same, and you can easily find the paper. It is very interesting to read this paper. Thanking you all. Thank you once again. I hope at least few of you you will be interested in the medical application of spectroscopy. Especially, it's a very emerging field in biomaterials, medical physics and all. Thanking you all once again. Thank you.